Hi all, welcome to Unit 3, Lesson 2. Our topic today is evaluating trigonometric expressions. I want you to pause the video and without looking at your notes, fill up the unit circle. So I filled out all the values. I just want to do the angles with you guys. So remember, around the circle is 2 pi, 0 radians are 2 pi. Half of 2 pi is pi. Half of pi is pi over 2, and then this would be 1 pi over 2. Pi is 2 pi over 2, so this is 3 pi over 2, and then 2 pi is 4 pi over 2, which is same as 2 pi, right? So if I'm going by increments of 90, that's how I remember these. So now I'm going to do, what's half of pi over 2? Pi over 4. So I'm going to do pi over 4. So I'm going to do all my quarters in each quadrant. So this is 1 pi over 4, 2 pi over 4 simplifies to pi over 2. This would be 3 pi over 4. 4 pi over 4 becomes pi. This is 5 pi over 4. 6 pi over 4 simplifies to 3 pi over 2. And then 7 pi over 4. 8 pi over 4 is 2 pi, right? So that's how we're coming up with these. Again, your pi over 4 family have the same coordinates, right? And only thing different is the signs depending on what quadrant you're in, right? Going back to, now we did that. Now let's do our pi over 6. So this would be pi over 6. So less than, you can do the adding of it by numbers. This is 1, this should be add 4, this would be 5 pi over 6. You skip, this would be 7 pi over 6. This is 11 pi over 6, right? Now I want to do the pi over 3's. So pi over 3, this is 2 pi over 3. You can actually go around. This is 1 pi over 3, 2 pi over 3, 3 pi over 3 is pi, 4 pi over 3 is right here, 5 pi over 3 is right here, 6 pi over 3 will be what? Your 2 pi, right? So this is how I remember the angles, and we're going to be working with angles. So let's get started. We're going to be working with angles and radians. That's what I meant. So let's get started with our example 1. So what does it say? We can use the unit circle to find the exact value for the trigonometric function in order to evaluate a larger expression. So our first example is given to us and it says find the exact value. Again, whenever we see the word exact, I always say do not put it in the calculator. You're going to use your unit circle and your memorization of the unit circle to help you find out these values, right? And I'm just going to quickly draw this up here. Actually, I wanted to do this color. It's ASTC. Remember, all trig functions, only sine and cosecant is positive, tangent is positive in the third quadrant, and cosine is positive in the fourth quadrant. So -5 secant square 3 pi over 4. Again, focus on your family. Oops. Your pi over 4 family is what? First of all, if you're not able to do it as of now, since we just learned it, find me cosine of 3 pi over 4. It will be rad 2 over 2 actually, and 3 pi over 4 is rad 2 over 2. 3 pi over 4 will be in the second quadrant, so it's going to be negative. So secant would be the reciprocal of it, so it would be just negative rad 2, right? -1. We're in the second quadrant, so let's check that. Or just write quadrant 2. Write that so that you don't make mistakes over and over again. I like to sketch the coordinate plane. That way I know which trig functions are going to be positive. Tangent is negative. So whatever value I find is going to be negative. So it's going to be pi over 4 is 1. So -1. Simplify this. I get what? -5 times 2 minus 1 over negative 1, which is negative 5 times 2 is negative 10 minus 1 is negative 11 over negative 1, which is 11. So that's your exact value for this. Example number 2. It says find the exact value of, we're given this really big trig function, and we want to find it when t is 11 pi over 6. So now what I want to do is, wherever I see t, I'm going to substitute that with my angle. My angle is 11 pi over 6. So I'm going to rewrite it. So I substituted a t for 11 pi over 6. And 11 pi over 6 happens to be in our fourth quadrant, where cosine is going to be positive, sine and tangent both will be negative, and this will be the points. These are the points, rad 3 over 2 and negative 1/2. So we're going to use these points and we're going to substitute in here. So sine of 11 pi over 6 is going to be negative half. Just going to put this in parentheses, plus tangent 11 pi over 6 is going to be negative rad 3 over 3, and this is all squared, plus cosine of 11 pi over 6 is rad 3 over 2. Remember, this square that's up here means that I'm going to take cosine of the value for cosine of 11 pi over 6 and then square it. So that's what I'm going to do, square it. And the secant is reciprocal of cosine, so this would be minus 2 rad 3 over 3, right? Squared. All over negative rad 3 over 3. So now the next step is to simplify this. I'm going to actually expand this, and if I do, I get what? It's going to be a positive, right? It's because it's squared. 1/4 plus, it would be 3 over 9, right? Plus rad 3 over 3. This would be 3 over 4, right? Rad 3 squared is 3, 2 squared is 4, minus this would be 2 square. 2 rad 3 square is actually 4, 12. 4 times 3 is 12, yes, over 9, right? Remember, the denominator is not squared, so it is as it is, negative rad 3 over 3. So if you simplify the numerator in your head, rather than taking the common denominator, all I'm going to do is, look here, 1/4, I saw that, 3/4. What's 1/4 plus 3/4? It adds to 1. Then I have, 3 9ths and negative 12 9ths. That add to negative 1, right? And then I'm left with just rad 3 over 3 and negative rad 3 over 3. These cancel out, and you divide something by a negative of itself, you get an answer of negative 1. So that's your final answer. I want you to finish the problem set